Hello everyone. In this video, we will do some examples in which we will use counting trees to find number of elements of sets. The first example is an example that we did before using different techniques. I suggest you pause here and read the question carefully, then see the solution. Okay, so for this question, we have three sets. U is the first year undergrad students registered at Western fall 2017. And then we have two courses, Math 1228 and Physics 101. So for Math 1228, we will use the notation M, students who took Math 1228. And Physics, we will use P for that, the set of students who took Physics 101. Okay, what information are given here? So the information are the number of the universal set is 2000. The number of elements of M, or the student who took Math 1228, is 1400. And N of P is 700. And there is also something else, both math and physics, so that means the intersection is 400. Okay, so now we are looking for different quantities. So let's first start drawing the tree for this question. So I will start with math first. So those one who took math, those one who didn't, then the ones who took physics, not physics, physics, not physics. Yeah. Now, remember the rules here. In the root, we put NU, which in this case is 2000. On each branch, we put the number of the elements or members of the intersection set of all the sets from that endpoint of that branch up to the root. For example, for this here, there's only one, so we have to put NM, which is 1400. And we for for example, for this one, you see if I go from the end of that branch to the root, there are two sets, P and M, so you find the intersection of those two, the number of elements there, this is 400. Okay, so let me just clean up a little bit. How about NP? Well, P is not in the first level. In the second level, there are two of them. And since there is no intersection, so we will take all the roots, all the paths ending to P. So this one, so let me use different color here so that it clarifies for later use. These two together will give me NP, number of students who took physics, which is 700. Yes, but I already know that 400 of them are the ones who took not only physics but math as well. Then the rest will go here, which will be math complement intersect P, which will be 700 minus 400, 300. This is N, M complement intersect P. So this is 300. And now these are the numbers that are given. We can go ahead and you try to fill out the tree, complete the tree. For example, the rule is here, the number on the incoming branch must be equal to the sum of the numbers on the outgoing branch for each point. So here, 2000 incoming, 1400 up there, so the rest needs to go here, which will make that 600. For this, the incoming is 1400, one of the outgoings is 1400, the rest will go to the other branch, so it will be 1000 here. And well, the same story here repeats, so we have 300s as well. Okay, so now we have all the information we need for this. Now let's see what the question asks. We are looking for at least one of these courses. What does at least one of these courses mean? At least one of the courses. Well, at least one course means that either taking two or one of them, yes? So this is basically saying that find the union of these two sets, okay? And for the union means you find all the paths which have, so let me just copy this, because I want to use that copy and then paste. Okay, I don't need to have all those extra information there. For example, I don't need to have this one, this here, that there, and yes. Yes, so that's the tree we are using, yes? So now, for the union, you find all the paths, which includes either P or M. In this case, you see this one includes P. This one, the path from the endpoint to the root, that's what I mean by the path. It includes M, so it will be included. This one includes P, although it is MC. This one is the only one. The last one is the only one which we don't need to include. So these all three are the paths from the terminal points to the root, which include either P or M. So N of union then, P union M is going to be sums of these numbers. Yes, 400 plus 1000 plus 300s, and that will give me 1700s. So this is 1700s. Okay. Part 2, math 1228 only. So let us see, what does this mean? Math 1228 only. Well, when it comes to the set theoretic version of this means what? The students who took math but not physics, because we are interested only in the math 1228 only. So that means that we are trying to find M and not physics. Okay, and well, I can again bring down the tree, but this one is easy. M intersect M P complement is whatever you see up there here. So let me just put a circle around that, and then the number is 1000. So I don't need to. So the number, the label of the branch, which is included in the path with both M and PC. Well, the number, the label there is 1000. Okay. The third part is physics only. Well, the same story now goes here. Physics only. Means N, physics, and not math. And in this case, well, the same counting rule applies here. We have this branch here, so the label is 300. Very last one, it asks for neither of these courses. So neither. So it means that they're not taking physics. Well, doesn't matter. The order doesn't matter. They're not taking math and they're not taking physics. Well, obviously there is one thing to do there, and that is another 300. This is the other branch you see up there. Okay. So this example was just an example to show how to use counting trees to find number of members or elements of a set.